How do you analyze a graph based on a lot of different characteristics? First of all, in this graph, what I'm going to do is look at what is the domain, the range of the function. It is a function because it passes the vertical line test. And what are the y-intercepts and the zeros? Y-intercepts and zeros. Zero is really the same thing as an x-intercept, or where the graph crosses the x-axis. So first of all, starting with the domain, I'm going to look at all of the x's that this graph is going to hit if you extended the graph. Now, if you extend this graph, even though it's rising at an increasing rate, it's still going to cover all of the x's in the left direction and the right direction. So that means that all of the x's will be covered as you go to infinity, as x goes to infinity to the right and infinity to the left. Therefore, the way that you can write that is interval notation from negative infinity to positive infinity. The range is going to be all of the y's that are covered. The y's that are covered in this graph are going to be from this point all the way extended up. How can you represent that? You're looking at the negative 16. The negative 16 is going to be the least or the minimum y value and go to positive infinity written like this. Again, bracket means including, parenthesis not including. Y-intercept, that's where your x is 0, that's equal to 0, negative 12, and the zeros are going to be negative 2 and 6. And look how I wrote the y-intercept. I put it as points. I'm not saying y equals negative 12, that's a line. I'm actually writing down 0, negative 12. Now, it also says find the y-intercepts and zeros algebraically. How do you do that? Well, you put 0 in for x and 0 in for y. So putting 0 in for x, you evaluate, you get negative 12. So that's how you get your g of x, which is negative 12. How do you solve for the x's? When your g of x is 0, you factor. And when you factor this, you're going to see that the zero product property says that x can equal 6 or x can equal negative 2, and therefore that's how you confirm algebraically that those answers hold.